program. For that, you just need to go to anaconda.com. Those of you who haven't done it, please do it. And just click on download and then go to installers, and after that just click on whatever, if you have Windows or Linux or Mac, click on whatever link is suitable for you. Depending on your graphic card, you will get different commands. If you have an iPad, you can go also to a Carnets app, and if you use the iPad, you can follow the lecture with this application. Okay, it's free, so no need to register or something like that. Just download it and follow the class on the iPad. Okay. Anyway, I hope you've done this. Once you do that, you need to click on a Jupyter notebook. Okay. And once you click on the Jupyter notebook, you will get such this, let's say, overview on your browser or the browser of your choice. If you have Chrome or Explorer or whatever you have. And after that, I guess you need to go to the folder you want to start and just go to New and then Python 3. Okay. And this starts a window that allows us to perform Python 3 programming. Okay, from very simple to very complex. We will start with simple and we'll increase the level. So now we go to here to rename, and I call this always like with same. Today's the 30th. 30th, right? Yeah. This is Supplier Management, and this is MB7. I call it rename, and then I always go and say save and checkpoint. Okay, so now it's saved and checkpoint, and we can start. We start today with a visualization of data. As we discussed yesterday, visualization is important, so we need to first learn how to visualize, and visualization is very intuitive, so we start with a visualization of the data. For this, we need to install and import certain packages. A package is, you can think about a package as, let's say, an application on your phone. Okay, so now we have installed the Jupyter Notebook, the Anaconda Jupyter Notebook, which is like the operating system of your iPhone. But that doesn't mean that you can still or already start with one application, like for instance WhatsApp. If you want to use WhatsApp, you need to install it, and then you need to open it. So first we install the application, the little package, and then we import it, which means we open it. Okay. So the first application we need is Seaborn, and we install it, and for this we call this symbol, admiration symbol, pip, and then install, and then Seaborn. Okay. Once we do it, I click on it. By the way, in order to, let's say, click on each window, you need to press Shift plus Enter. Okay, so this is important. Otherwise, you cannot call. So whenever you you want to run this window, you press Shift and Enter. Okay, so it tells me that the requirement has been already satisfied because I have already installed it in the past. For you, the first time will be different. And then I need to import it. Import Seaborn as SNS. By calling Seaborn as SNS, I am creating a variable SNS. So every time I write SNS, Python understands Seaborn, so the application. Okay, so import it. You see here a star while it's thinking, and then once it's done thinking, you get a number. Okay, so once we have installed it, this is a very powerful package. We load a dataset from the program called anscom. Okay, and in order to load a dataset, we do it like this: SNS, so Seaborn dot load dataset, and then the name of the dataset. And then I press, as always, Shift and Enter. Okay, so the dataset is already uploaded. You see the number 6 here means we are done. And then I say let's look at anscom. Okay, so we see here the dataset. It's 44 data sets. Okay, the first column is one class, 1, 2, 3, 4, 5, 1, 2, 3, and 4. No, only 4. Then the second column is one coordinate in X in the horizontal, and the third column is one coordinate in the vertical. Okay, so we have 44. We start with 0 always and end with 43. So we have 44 data sets, data positions, and 4 classes, and then there are points in the space. Okay. So after calling the data set, we create a subset. We choose the data only from class 1. Okay, so we want only, let's say, the data from the first 11 positions. So we go like this: dataset 1 equals anscom equals equals 1. Excuse me. So as you have seen, I have used square brackets because this is a list, an order list. Okay, so if I now say print dataset 1 underscore 1, it will give me only the first 11. He has looked at dataset, at the column anscom dataset. It has looked where this column equals to 1, and then just chooses all the data from that. Okay, So now we have the data set, we can start visualizing. We use also another package called matplotlib. We need to install it, and we need to import it. Okay, I do this in the same line or in the same window. It says the requirement has been already satisfied. We see here the number 10, so it's already done. No errors. Within matplotlib, I only import pyplot, which is the library that helps me plot. So now let's start splot. I called plt because I have created a variable called plt, which means matplot.pyplotlib.plot. And then I say, okay, please plot me the dataset 1 with symbol x, the column x, and the dataset 1 column epsilon. Okay. And the thing by default plots me a 2D line. Okay. By default, PLT plots a 2D line. Good. So the thing has just taken all the points in the dataset 1 from the column x and y, and then has taken that and has put the whole thing into a plot. But I can change this plot, change the plot to a scatter plot with points, okay, by just writing the same thing, plt.plot dataset 1 x, so the first column and then the second column. And then I say, okay, just do not write me as a line. I say write me points, and I do that by writing a comma and then an O, and so the things it's just writing me or plotting me a I guess I can change also the color. I'm not sure if it's like this. Yeah, so I can change the color to green. You know, you can do a couple things. Default is blue. Okay, any questions so far? Hello? Questions? Okay, I guess you're not very active. I'm not sure why, but I guess it's your decision. Okay, so now I give you an exercise. If you have any questions, you want me to be more slowly, or you want me to repeat anything or any concept that you don't understand, just let me know. Please represent following datasets graphically. Okay. So you can do that on your own. Okay, let's continue by representation of statistical data sets. We called another data set called tips. Print tips head. If I called head, if I called head, then I get only the first 5 positions. Okay, so what we see here, and it's good also to say tips dot head, because it helps us have an overview of the first data sets. So what this means, what this is describing is the amount of tip, the amount of what was paid in a restaurant, total bill, how much tip was given, the sex of the tipper, female or male, smoker, was it a smoker or no, on what day, was it dinner, lunchtime, and how many people were in the at the table. Okay, so the total tip, the total bill, the tip, the sex, the smoker, the day, and the time. And we want to plot different things here. Okay, so the first thing we're going to plot is a histogram, which is one variable representation. Okay, so we're gonna plot as an example the frequency of total bills. Okay, for that we follow always the same structure. Yes, now the first time is more difficult, but I will try to explain each line. So the first line is you create a, let's say, reserve some memory for the plot. This is necessary, and we call that by creating a variable. Axis 1 is going to be the name of our plot. Add subplot 111. So this creates a mosaic of one picture in horizontal and vertical. Axis 1, now we set the title. No, sorry. First we tell him what sort of plot we want. So we want to plot the tips. We want to plot total bills, the total bill. And we're going to group it by 100. Okay, so I want 100 groups. Let's say we tell Python to plot a histogram of the column total bills with 100 groups. So after that, we set the title, axis 1 dot set title, histogram of total bill. This is the title of our axis 1 dot set x label. the label for the, this is the title of the histogram. This is the label for x-axis. Set y label, same thing. Y label is called total bill. Label for y-axis. And then we just say, show me the figure. Okay. And we press, of course, Shift and Enter in the end. So once we plot this, we get our histogram. Sorry. So you get, we're getting here 100 groups. It's grouping the tips, the total bills. Excuse me. So it's grouping the total bills in 100 groups. I can also only group the whole thing in 20 groups. So I get a sharper, a less sharper thing, or I can I don't know, 150 groups. Okay, so it's less sharp, and so on. So I'm gonna make 100. This is kind of what we started with. Okay, so any questions to the histogram? Okay. The second example is a scatter plot. So here we have two variable representation. Here is kind of the same. We're gonna be printing, let's say, the total build versus the tip to see if there is a correlation between the example total bill x-axis and tip y-axis. Okay, so the scatter plot is plt.figure. We reserve the memory again. Then we tell him it's just as before. We tell him what we want. We want the scatter plot. Axis 1 is the scatter plot. And we need to tell him to add a subplot 1, 1, 1. Then we tell him what we want to do. We want to have the tips, the total bill, versus in tips the tip. And we set the title. Versus tip, and then we set this the X label, and we set the while label. So we say scatterplot, plot.show, and it's printing me the total bill versus the tip. Okay, so as you see, the more total bill, the more we pay in the restaurant, the more tip people give. Okay, there's sort of a correlation that we will be looking at later. So, questions to the two variable representation? Okay, no questions. Well, we had now two examples of numeric variables, but we not only have numeric variables like total bill and tip, we also have female or smoker or the day of the week. So how do we plot, let's say, the tip given by sex? Okay, depending on what sex people have, what is the tip being given? For that, we use box plots. Box plots, you know from statistics. Plot one categorical variable. Categorical variable is sex, female or male, or undefined. Plot one categorical variable and numerical. Okay. So, and in the example, we plot a box plot of sex versus tip. Okay, and so first we reserve some memory, just like we did before, figure. Then we got a subplot, box plot, dot add subplot 111. Then we define the box plot. What do we want to get into our plot? So what do we want to get? Is first we want to get tips, and from tips the column sex equals female. And the second, we want to get the tip. This is the first box plot. Then we want to get from tips, we want to get tips of sex equals male and against the tip. And the labels of each box plot are going to be female and male. Female and male. Good. Once we have our box plot, access one.set x label sex. This is the x label. Dot set y label tip, and then access one set title. As you see, the order is irrelevant. Box plot of tips by sex. Then I say box plot show, and yeah, you get the box plot. You know, this is the median and the third Q, the first Q, and you know, all the statistics behind. Female, so this first order is telling me to get the female versus tip. So whenever tips, the column sex by tips is female, represent that against the tip. Okay, and the second line of the box plot gets me the right description. So whenever you get a male in the column sex of tips, represent that against tip. The labels female and male are here, female and male. If we change here label sex 1 and sex 2, let's see what happens. You know, again, sex 1, sex 2. So you can play later with all this to see what happens by changing the variables. So, questions, please? So, now you get an exercise. There is no questions. So now represent several plots, several box plots. For instance, tip versus smoker versus time or versus day. Smoker, day, or time. This is for you to do whenever you are at home learning. One question that people often ask is how this is dealt with in the exam. So I just maybe I might give you a this, okay, and then I might tell you, well, then please give me the code to represent a box plot for smoker versus tip. Okay, so you need to give me this code in the exam. This code change so that you get smoker versus tip. Okay? Verstanden? So, hallo? Es wäre nett, wenn ihr hier irgendeine Rückmeldung gibt. Eine, okay, ja, verstanden, gut. Alles klar. The idea is, the idea is that you, and this is how you should learn, that you write this code without looking at the exercise, because this is the way the exam is going to take place. So, multivariate datasets. We are going to plot many variables in one plot. Okay, and for this we're going to make an example of a scatter plot of the total bill versus tip, separated, colored by sex and size, by sex and sized by amount. So we're going to get this total bill versus tip, but the points are going to be having a different color depending on who gave the tip, male or female, and the points are going to be bigger or smaller depending on the amount of the tip. Okay? So for this, we first need to recode sex to a numerical variable. Okay, this is important. Now, sex is a categorical variable, it's a class, it's female or male, and this cannot be coded yet. So for that, we define a function, recode sex, that applies to sex. Say if sex equals a female, double point, then return a 0. If else, return a 1. So what this does is if the variable sex is female, then transform it to a 0. Otherwise, transform it to a 1. Okay, this is what it does, this function. So now we add a column to our data set with the sex recoded. In order to do so, we say tip sex color equals tips sex, and say apply recode sex. So here we apply the function recode sex to the column sex of tips. Okay, once we do that, and let's say we print now again tips.head, same as before, we see that we get a new column that was not there before, called sex_color, with a 0 if the sex is a female, or a 1 if the sex is a male. Okay, now please do an exercise. Recode smoker, record the variables smoker, yes or no. Day, now in days you have 7 days, not only 2, so you need to think how you change the code. And time, dinner or lunch, okay, so that you get numerical variables. Okay, and I guess you are experienced enough to know that all these exercises are kind of like what later on will be asked in the exam. So we go now and we plot the example as a promise. Scatter plot equals plt dot figure axis 1 equals scatter plot underscore add subplot 1 1 1. So we go axis 1 dot scatter. This is the same as before. And what do we want to represent? So we want to represent x, it's tips, total bill. So we know we want to represent the total bill versus the tip. So the epsilon y is going to be tips tip. That's cool. So now the size, okay, is going to be tips size do I have the size? No, I don't have the size. Tip times 10, comma, the color is going to be tips, sex color, and alpha is transparency. So this is transparency. This is the size. This is the color. And the rest is just the same. So I just copy it from my repository. Just the title. Total bill versus tip colored by sex and sized by amount. The total bill and the tip and so on. So I click on Shift Enter and I get the representation. I can get this a little bit bigger, maybe. So, okay, so now we have the total bill versus the tip. Before we had only points, okay, but now I get different colors. Yellow is male, and can I put a legend? Will it work? No. I don't know. What is the syntax now? Anyway, you get by two colors or separated by colors with this new variable sex colors, okay? Questions? Can you follow? Okay, no questions are coming. I wonder why. Okay, well, then I continue. Exercise, represent total bill versus tip by daytime, and another exercise, represent total bill versus tip by smoker type. Okay. So now we have a representation of a histogram. We had it before with a density plot. So the Dichtefunktion, the density function in what we know from statistics. So here we have, this is an example. Here we want to represent two plots in one figure. So what do? First, we know we have the, I don't know what happened. We have the histogram on AX. So we have two things we want to plot, plt.subplots. Then we define what is AX, which is this plot, okay, which is a density histogram plot. So D for density and ist for histogram, density histogram, this plot. And here we have the tips and the total bill. So density plot plus histogram. This is defined. Then we go AX set title, total bill histogram with density plot. And then we go plt.show, press shift enter, and sex title, no, set title. And we get the thing plotted. You see the histogram, just as we had it before somewhere here. And we have the density plot, which is, let's say, approximating the histogram in a way that is a line, okay? So we can have some variations of this. Let's say I copy this, and then I say histogram false, okay? Let's say here I say without histogram. So density plot without histogram. Histogram false, and then I press shift enter, and then it only represents the histogram, okay? Okay, you can follow. Questions? We can also plot a bar plot, which is also a very useful thing to do. AX PLT subplot AX conplot. Let's say day. And you need to tell him where is the data. The data is in tips. Set title, count of days. And then I said set while label. Days of the week. And then frequency. If I say plt.show, it shows me what is the frequency of the people going to the restaurant by days. Okay. Some statistics. I can do a linear regression. You remember from our statistic lectures a couple years ago with the scatter plot. A linear regression, it's also straightforward with this. First I reserve some memory, then I say, well, AX is our regression plot. Okay. I need to tell him what I need to regress. Well, we need to regress the total bill and the tip, and the data is in tips. And then I set the title and blah blah. So this is just the rest is just the same. I can copy it, and you see it gives me the scatter plot, okay, the points with a regression line and a confidence interval. I can also get a joint plot, which is a scatter and a histogram in 2 dimensions. Okay, this is something that, for instance, Excel cannot do. You can get way better, way stronger points with this if you know how to use it. Total bill, and then you get tip. Data is the tips, and just by changing, well, now I tell him I want the axis labels and my axis labels and my subtitle. Okay, I can get a joint plot, which is the scatter plot. Okay, the points we already had, with 2 histograms, one for total bill, which is the one showing up, and one for tip, the one showing on the right. Okay. Sometimes the scatter plot is not very useful because there are too many points. So sometimes we like to represent a hex bin. Hex bin, it's going to be representing the density of scatter plots with hexagons, and this is something that of course Excel cannot do. Xbin is sns.joinPlot, and we just tell him X the total bill. Wait, X is called total bill. Y is called the tip. Data, it's coming from tips, and I want the kind hex. Okay. The rest is the same as being subtitle is superior title. So as you see now, I get hexagons instead of points, and whenever the hexagons are darker, it means that there are more points. But this is prettier, I guess, and more powerful in the communication. Okay, and last, we can get a density plot 2D density plot. Remember here we got a density plot, but it was just for one histogram, for one variable, total bill. Now let's say we want to get two, total bill versus tip. And in order to do so, we get KDE AX PLT subplots AX equals SNS dot KDE plot. Data, I get the data from tips, total bill. Data 2 comes from tips, tip, and the shade is true. Please shade me the whole figure. KDE means KDE equals kernel density plot. Okay, something called kernel density plot. And just call the title label and Y label, which is straightforward by now. And then it does me this density plot. Okay, so which is kind of with the same information as here, but in a different manner. I guess some people might think this is prettier. You can see here very well that the center of mass of this distribution is I guess $13, and people give $2 tip for that, so that you get to 15. Okay, so any questions so far? Irgendwelche Fragen? Any questions about the exam, how this thing is going to be being asked, or you have any concerns? Irgendwelche Fragen auf Deutsch? Keine? No questions? Okay, I guess your call. The information will be uploaded on profh4.com. Just click on lectures and then go to the playlist Supplier Management Winter Semester 221, 222 MBW7. Okay? Good, and I send you this information on a PDF, this code on a PDF. Please make sure you start today with this, because I will not stop until the end of the semester giving you information, and it's going to be, I assure you, it's going to be tough for some of you. Okay, so please make sure that you get on top of this like white on rice as of today. Okay. If you have any questions, you have my WhatsApp number on the website. You can contact me anytime. If you don't get the program installed, just call me and we fix it. Don't wait until in 3 weeks, because in 3 weeks we'll be seeing completely different stuff. So just start today. Okay. Yeah, anyway, I guess I hope you have a nice week, rest of the week, and enjoy the Herbst week in Schwäbisch Hall. Goodbye.